Okay. So yeah, my name is Cory Gideon. I'm a manager consultant with Sogeti Capgemini. I've been working as a software engineer and architect for over a decade now. So I've been all over the stack from back end to purely front end to infrastructure pipelines, DevOps. So kind of all over the place. And during my tenure here as an engineer, one of my biggest pet peeves that I've noticed within the tech space is leadership pushing for a solution such as micro front ends that they hear about at a conference or read about in a trade magazine without really understanding the full problem that they're trying to solve. This causes a lot of headache for architects like myself or your dev teams, your front ends, your BAs even. So that's one of the things that I want to make sure that we cover today is there are no true silver bullets for solving every problem in tech. Um, so you're at a conference on micro front ends. I'm assuming you have a passing knowledge of what a micro front end is, but what it from a very high level, micro front ends are applying your microservice design patterns and architecture to your front end applications. So this allows you for smaller applications that orchestrate together to form a cohesive UI. But I want us to get real for a second. I'm not here to tell you that a micro front end is the end all be all of UI architecture design. Do they have their place? Absolutely, they do. But on the same side of that coin, they are not meant to solve every single problem. Just because we have this new hammer doesn't mean that everything is a nail. This pattern of architecture in design calls for a very specific approach to your system flow, your DevOps pipelines, your application development lifecycle, your data architecture, and even your team structure. It's not a simple lift and shift process to get from a monolithic UI into a micro front end UI. So all that to say, you're going to see different results based on each problem, even if you have two applications within your same team, your same company, you are not going to be able to copy paste your design patterns into that. So not everyone, in fact, most people should not use micro front ends because they can make things more complex. But who should use it then? Well, if you have multiple front end teams who are working on disparate features, it might make sense to evaluate using micro front ends. And if your application is too big, you have this gigantic UI, this gigantic front end app, then it might make sense to decompose it because you don't want to spend hours doing a build testing. So then it might be make sense to decompose it. Or if you want to have independent deployments of different parts of your application, then it would make sense to do a micro front end. So just a little bit of a history lesson. So in the past we had the monolith. Everything was in one repo, everything got built and deployed together. I needed to change um, say I wanted to change the format on my products, like product definition or product details slide. Then I'd have to build the entire app, including services that weren't part of that front end. Uh, More recent past, we split the front end from the back end. There were still monoliths, but I could change the front end without deploying the back end, and vice versa. Our current present is we have our microservice APIs, and we have that API orchestration layer, and then we still have this monolithic front end, so we could deploy our recommendation engine, uh, pers- for example, without deploying our payments processing and our customer management APIs. And our micro front end wouldn't know the difference unless we changed the unless we changed the API endpoint. So the not so distant future, we have micro front ends where we to still have that microservice backend with our API gateway, but then we also have our like a basket UI and advertisements section, product section, and all those are in our orchestration layer. So you can kind of see that we're applying that same paradigm to our front end. So in short, you're microservicing all the things. You're kind of following that same design pattern, that same ideal in the front end. And you can use a lot of different UI frameworks. So React, Angular, Vue, Ember, Svelte. There's a lot of different options. And a benefit of MFEs is to be able to use whatever front end framework you want and stitch them together in your orchestration layer. So there's a few examples of who's using them. I'm sure you're again all aware of this, but some of the big names is IKEA, Spotify, Zalando, Dazen. Um, so we have e-com sites, music streaming, video streaming. So there's a lot of different industries that this is being implemented in. So say you have this monolithic UI and you want to look at how you can start splitting it apart. So you're an architect, your boss comes to you and say, "Hey, we want to take this monolithic application we have and split it we want to split it into micro front ends. How are you going to design it?" Well, one way you can do it is you split it by domain. So you have your sales team, your recommendations team, and your customer teams, and they are all responsible for their own front end, back end, and database. But I hope you kind of see an issue here. You're not really developing micro front ends and microservices here. This is a distributed monolith, micro monolith, if you will. Not to say that that is bad. There is a place in time for monolithic design patterns. You just really need to think about it. Another option is bisection. So your body is its own front end app, your header, your footer, and your nav. So that is a one really good way you can split it apart as well. Now, this is just an example. I don't think Amazon's using micro front ends, but you can also do it by functionality. So you can see here we have all these little tiles that each one of those could be a front end or micro front end in and of itself. Your taskbars, your search, all of those could be independent of one another. And lastly, I want to talk about you can do it by page. So this is the one that this is how I usually prefer it. Um, especially if you're doing a procedural application process, say for applying for insurance or signing up for an account. Page one is its own application. So let's say I'd be listening on port 8001. App two is listening on 8002. So we have that orchestration taskbar, which when clicked will pull up in either an iframe or um, any other application, uh, any other pattern you want to follow. It'll pull those up and share it, share that content with your end user, so you can deploy app two, app three without having to impact app one. Um, as I said before, there are tons of potential benefits but there's also a ton of potential drawbacks. And the drawbacks is what seem to be skipped over a lot when we're having these discussions of what we are trying to accomplish and what we are trying to solve for. Only teams tend to get excited and only focus on the positives and using the new shiny thing. Um, so start with independent teams. Some pros: your teams are isolated from one another. It's great. You don't spend a lot of time orchestrating releases and coordinating your changes. You can allow the teams to do what they do best, make cool stuff. Um, they can also help facilitate your team independence from one another. I can release on my schedule without team B releasing on theirs, or without having to rely on whatever team B is doing and tying our releases together. Again, this kind of goes back to reducing the coordination with other teams. Team A can do their own life cycle; they can release when they want, and Team B doesn't need to know; they don't need to care. So those are some pros that I've heard in conversations when we're discussing micro front ends. But the cons of this really assumes vertical ownership of the stack. That doesn't happen very often. your your customer team doesn't always necessarily have ownership of their own customer data and the customer APIs. Usually that's another team. So that can be a pretty big sticking point and have to require some coordination with leadership. And as we saw earlier, it's really easy to develop a distributed monolith this way. In distributed monoliths, you're just running into the same issues with a regular monolith, as well as you have to worry about the communication between the applications. And your teams might not be spread thin, but your architecture is, because you have you have customers, products, and recommendations. Those teams are independent of each other, but your architects have to figure out, how are we going to get all these working together? How are we going to maintain data integrity? How are we going to follow compliance, making sure that everybody is following the same rules? Um, Code organization is another really good reason you don't want to have these gigantic repos. So each micro front end is really specific in what it does. That means that my recommendation UI pulls up, hey, you've bought this in the past. We think you might like this product 1, 2, 3. So we know specifically what that does. And in general, there's less code to maintain. So yay. We don't want to worry about trying to spend hours digging through code trying to figure out where a bug is. We know where this application's small. We can find it pretty easily. And this one, it can CI/CD can become much easier because each application can be built independently. But in reality, this can really cause some issues because we think that applications can be split there and completely independent of each other. Most of the time, that's not the case. Some cons: if there is a shared app, it can quickly become a dumping ground. So I'm sure everybody in your kitchen has this one drawer where your batteries go, pens, papers, rubber bands, random little things. So that can happen in micro front ends and even microservices. You have this common library that's shared across all of them, and that just architects are spread thin. Just shove that code in the common library, and we'll figure out where it goes later. Well, nobody figures out where it goes later. You have this gigantic junk drawer application that has tons of disparate features that don't make sense to go together. And it can really cause you to lose the benefit of some package managers, which leads to, if you have different versions across multiple front ends, then it can really become a nightmare, especially if a vulnerability is found. I don't know if anybody remembers. This is more back end, but the Log4j vulnerability that happened last year, I believe, that is just a good example. If you have for three multiple different versions, so you have this critical open source application, multiple different versions of it, a vulnerability is found in version 2. Now you got to figure out what front ends are using version 2. How do we need to upgrade? Do we need to go from 1 to 3, or do we have to go from 1 2 to 3? So again, it can become this fire drill of figuring out what is happening, what needs upgraded. And it can also be difficult with my front ends to find out what app does a specific action. If your naming conventions are wrong, if you're not really making sense, then it can really have problems with finding out what's broken and where. There's also we have, as you can kind of see in this tweet, there's all these different microservices. Hey, great. We're leading the pack here. We have all these different microservices, all these different micro front ends. We can deploy these tiny little pieces whenever we want. Well, what about your orchestration and your testing? Yeah, it turns out that that's can not necessarily be a big issue, or can be a big issue, excuse me. And then as a consultant, you have someone like me who comes in and talks to your leadership. I So there's consulting companies that I worked with in the past that are going to sell the golden goose. We're going to just answer yes to whatever you're trying to solve, and we'll figure it out later. That leaves the application teams in a lurch because now your leadership's been sold this ideal, and now you need to figure out how to do it. So buzzwords. I mean, that I'm sure that's common everywhere. Every company is vulnerable to falling for the buzzword hype. Micro Frontends could be a buzzword in your in your organization, but they just would require some pretty deep knowledge of how things need to work. Yeah, release independence. So in theory, you could release a specific small part of a front end. So release your cart without impacting anything else. And it can really push for that shift left mentality in your teams. And if something goes wrong, you can roll back that release without impacting your whole front end or your whole site. But more often than not, your front end will have links between applications, and this reduces your independence between your applications. And not releasing unchanged code. So if there is that link, you're coordinating between team A's team B. Team B has a front end that requires a connection to something that team A is doing. They're supposed to release at the same time. Team A pulls their release. It could be an issue with, well, now team B can't release, or they're going to figure out a way to or remove that link or reduce that complexity, as well as with backends changing, APIs being updated and going from version 1 to version 2, version and then deprecating version 1 API endpoints. Now they have to let everybody who's using that know, hey, this no longer exists. Reducing testing complexity is a big pro that I hear a lot of my QA colleagues pushing for MFEs. Um, so fewer code changes and release theoretically reduces testing. Well, updating one app doesn't mean that you won't break another application, especially if there is a link that you're not fully aware of. And it will also take more time to architect the solution to ensure your application independence. So having one app updated doesn't mean that you don't have to test multiple apps. You still need to know that things are working correctly. So with our build times, this isn't, I mean, in theory, small individual clients could lead to shorter individual build times, but it can actually increase your build times as you are now actually having to build multiple apps in order to test connections and your workflow, leading to multiple test suites that need to be run. Okay, technology independence. As I mentioned earlier, we have all these different front end frameworks that can stitch together. And I want to use Team A wants to use Ember, B wants to use Vue, Team C wants to use Angular. Great, you can make those independent decisions on your own, and then allows for a simple upgrade path in the future. But multiple frameworks on one screen can crash certain devices, and it can become very complex if you are trying to have cross-functional teams and move teams from Team A, or members from Team A to Team B. Well, if Team A is using Vue, Team B is using Ember, now your devs have to know both. So it really is that it really is complex. And in all honesty, I've never seen a client or a company that's been okay with this, being using multiple front end frameworks. Um, it might just be specific because I'm working in more in fintech, financial technology, so fintech. But the the company's usually like, no, everybody's using Angular, everybody's using React, everybody's using Vue, so you don't really have that. I've never really seen technology independence uh, be accepted. So some more potential gotchas. Having conflicting styles. So making sure that you have that consistent brand image across your entire site, especially if you have each individual application having their own CSS, and your potential solution is to use a shared library. Potential solution is you can use a shared library and have that has all the styles for everything that you want to have. Um, Multiple frameworks requires a lot of CPU, RAM, and bandwidth, so having multiple on the same page can really bog down a site. And there's a way you can get around that is using cache to store your data in a place that's accessible from all applications, all apps as that need it. Um, App communication. Apps may pull the same data, thus slowing down your server. So this really would cause you to have to use local storage or cookies. Um, but there's a caveat of that. That communication really introduces overhead. And then team communication. So finding reusable components and features becomes much more difficult across multiple teams working on multiple applications. Um, so really, you need to have that communication pipeline set up. That I'm working on this specific widget. Would anyone else find that useful? And I've usually done this in our sprint demos. We have clients I've worked at. We have our sprint demo for the business, and then they leave, and then tech comes in, and we have our demo there where we say, okay, I created these components. Do we need to move any of these out into our shared libraries? So one thing I would really want to encourage you to do is really think about how you see this working for you, and really think about that. Do we really need to do this? How are we going to do data data integrity and data sharing? How are we going to do application communication, shared libraries? Just really think on those benefits and gotchas. Um, so we went over the pros and cons, some reasons to do it, some reasons not to do it. So let's get into the fun stuff. How some tools out there that we can use to do it. So Project Mosaic, I really like this one. It's diffi- difficult to get set up in my opinion, but it's very powerful. And this addresses the breakdown of monolithic UIs using fragments that are composed together at runtime. So an example of how it's set up. So you have Skipper, which is an extendable HTTP router that is on top of a reverse proxy. And Skipper handles your service composition. It's very handy for decoupling routing from your server logic. And Innkeeper talks to Skipper. And Innkeeper is a RESTful API that stores your routes so they can be fetched from by Skipper and allows multiple teams to manage their own paths. Tailor will then is your layout service. It uses streams to compose a web page from fragments, and it's sort of a middleware on top of your Node.js server. Quilt is your template storage, which is used by Tailor, and there's a REST API that it interacts with. Shaker is your library and living showcase for UI components. So this really can facilitates, excuse me, your consistent user experience. And then fragments, these are your micro frontend applications. So this is a really powerful architecture and way of doing it. But as you can see, there's a lot of different parts, and it can be fairly difficult to set up. Um, Module Federation plugin. So this is another really good one, and now it's even part of Webpack. Um, so MFE, Module Federation plugin allows loading separate compiled and deployed code into your applications, and it works for both plugins and micro front ends. And it's really simple to use with Angular because it's part of the Angular architects library. So an example of how this is set up, this is in the webpack.config.ts. So we are just creating a new module federation plugin, giving it a name, a file name, so where it's going to be dropping into, what it is exposing, and some shared mappings. So really simple to set up and add. If you wanted to add um, another micro frontend app, you would just add another um, new module federation plugin to this list. So this is a example from a shell app in the app routes.ts. So I'm telling it for flights, want to load in this remote module, so MFE1, and expose .module. So you can see back here, so the name MFE1, so that app.routes is loading in this plugin. Um, so this is in our that top one, the declare module MFE1 slash module, that is in our decal.t.ts. And then in the app module.ts, we are include your app.routes, and you're good to go. Single spa, this is another really powerful one. It's a tool that is used to bring multiple JavaScript front ends together in a single application, and this allows you to use multiple frameworks on one page, and it also supports the lazy loading of your components. So this is kind of an example of how single spa is set up in the index.html. We're loading in our AngularJS, our navbar, and our home. So then in our single spot.config.js, we're doing this register application of home. We're importing source home app.js, and then our navbar. So again, pretty simple to add in new components. Eve, if size is an issue with your app with your library, so you're loading in a ton of other things and you really don't want something big, Eve is a good option. There's only 10 files, and that's it's very small, even not minified. It has 0 dependencies, which is great, so you don't have to worry about supply chain injection attacks and things like that. Um, and your base application creates your shared event listener, and your micro apps, your micro front ends would publish events and basically follow that pub sub model to that listener. So pretty easy to do if you're familiar with that pub sub model and that message queuing model. Um, this is the one that I've seen used most, is using Nginx. So using Nginx as your web server or reverse proxy to serve static content, and then you route the appropriate micro app based on the context path. And it's better suited for when there is navigation or routing involved, and the app is divided by feature. And pretty easy to do. Um, so you define your HTTP server in your Nginx config, and you have the location, so slash flights. So you then um, try files URI slash flights. Same with customers. So it's pretty easy to then route that to your different applications based on where you need to go. Uh, I've I've seen this one recommended on some uh, some sites and some books. I've never actually seen it being used. Um, but this is really when all of your functionality is on one page. It might make sense to use iframes, and if they're communicating through the DOM, that's a good reason to use them. But this also requires some additional security to prevent your iframe jacking. So this is an insecure example of how you can do it, but you have your your source application, then you define a couple iframes, and you have localhost 5000, which is going to app 1, and localhost 3000 slash flight search would be going to app 2. And it's simple to do. I don't like this because I don't like iframes. They make me really nervous with security. So, or you could write your own custom orchestrator. I I tend to fall into the trap of I'd rather build than buy. Um, so you can write your own orchestration tool to handle micro front-end orchestration. And so all individual projects are deployed independently, and the orchestrator can load each project based on the URL, and you can write this in plain old JavaScript. So Example how that works. So you have your own orchestration. Your request comes in from your end users, and uh, they say they want to go to the second application. So your own orchestration layer would then route to that specific application. Testing. This is all can be kind of a touchy subject, but how do you test a micro front end? Oh, really, there's not a lot of difference between testing micro front ends, monolithic front ends, and micro front ends. So each application should have its own comprehensive suite of automation tests. You just would treat it as if it was a standalone application. Um, your functional tests, though, between your micro apps need to happen at that base application layer. So app one does not need to test connections with app two. It needs to test specific to app one. Same with app two. App two needs to test itself and not worry about app one and app three. Your orchestration layer, that is what needs to test that everything is working correctly together. And keep your tests focused on integration, not business functionality. Don't go crazy testing the whole app. Keep your testing pyramid in mind, and your base tests should only cover what isn't tested already in each individual micro app. So it does not need to double up and to retest the same things that have been covered already. So how do we handle errors? This is another big one that have spent a lot of time in architect meetings discussing and trying to figure out. So each micro front end is responsible for its own error handling. It's great, but if we have 20 apps, I don't want to go looking at 20 different log files for an error. So main point of micro front ends is to prevent the whole site from crashing if one app experiences an error. So what we will do is we log each app's exceptions and into their own location, but then we'll have an aggregation tool such as Splunk that will then gather all of that log information into one location so we can find out from one area what happened and what went wrong. So air, you can use App Insights or whatever your coordination or your aggregation framework tool is of choice. Um, Authentication. So sharing authentication between apps can cause a bit of heartburn, uh, especially if you're having to uh, pass tokens back and forth and making sure that this user actually has access to view these applications. Um, you can get through some of this authentication issues by using your local session storage. So in prod, you normally serve all your apps from the same origin. So this allows you to store your token, and then your apps can access this token in the browsers using Windows local storage. Another option that I really prefer to use is cookies. So you can store a token as a cookie as long as it's less than 4 kilobytes in size. And with Jot, you store the token in a cookie rather than in your session ID, so it's fairly secure. And your server then reads in that cookie and fetches the user's session based on the information from that token. Um, this is one that you can do. I don't like this one because it's a URL parameter. It's not secure. The apps are usually run on multiple servers if your apps are run on multiple servers because they have different origins, then you can add your token as a URL parameter when you redirect from one app to the next. So passing it as a URL param will just do assign our token equals to some token, and then to read your token, you use query string.parse Windows location to search. So it's fairly easy way to do it. Um, Again, I don't like it. I don't prefer passing tokens in a URL. Um, Custom libraries are a really good option as well if you want to roll your own. So using a custom library is a good way to provide authentication in your shared code, but it's shared code, so it can lead to breaking changes. So you just do an ng generate library auth lib, creates a library project in your Angular workspace. So an example of um, what a tsconfig for a simple library would look like. And then you would add this to your apps in your webpack.config.js. I apologize. I went through that a lot faster than I was anticipating, but I really want to thank you all for your time. And I guess we have some time for some questions.
Yeah, thank you, Corey. So now let's recap. One of my favorites in your talk was the micro monolith. There's a funny name. I like it. And yeah, so very interesting to think about. It is not everything which is new must be the new silver bullet. And so we got some questions from the chat.
Mhm.
Um, just give me a second. Uh, the first question for Robson. So, mixing multiple front-end frameworks among micro frontends is not very common to reduce tech complexity, enable genuine teams, etc.
Yep. Um, this might just be more. From what I've experienced being in the U.S. With my clients, especially in fintech, they don't like giving that sort of autonomy. They don't want to. Teams don't want to um, have to learn multiple frameworks because we're mostly doing full stack. Um, and primarily around here, specifically, it's either React or Angular. Choose one. So yeah, it's not very common. It can be because they're so different and there's new frameworks coming in all the time. Um, they really don't like the having multiple frameworks on your same application on your same app. And I've only really experienced app crashes on using mobile browsers. And that was a couple years ago when we were testing some micro front end using. We had Ember, Vue, and React all on the same page, just as a proof of concept, and that crashed every mobile browser we were trying to use.
Okay. Um, so the next question: how could the more distant future post micro frontends and microservices look like? So you need your crystal ball.
Yeah, give that a shake here. It's kind of funny. So when I first started 10 years ago, we were full on decompose your monoliths and start going into microservices. And recently, I've been seeing a lot more push for that sort of micro monolith application. It's not. I don't understand why they're really pushing for that, but everything in tech is cyclical. So we're kind of wrapping back around and hitting that uh, monolithic design patterns again. So I really think that we're going to start going towards that micro monolith design, or another one I've seen a lot is your mono repos, where you have 10 different applications that are built in your CI/CD pipeline separately, but they're all in that same repo. So that's kind of where I'm starting to see things go, but we're still very much in that microservice and micro front end, slowly adopting micro front ends, but I don't see that going going anywhere anytime soon.
Okay. So the next question comes from Sasha. To ensure that links between apps don't break, doesn't this just shift integration tests to the shell layer? And doesn't this always couple shell and micro frontends in terms of CI checks?
Yes, it does. Um, that is again an issue with not following the true paradigm of app independence. So
That
if you're following the purest view of like a microservice, it is always separate from each other. This does not, in my experience, caveat with that, this does not work outside of paper. Um, so yeah, it does just shift your integration testing into your shell layer, which makes that huge. And the shell does couple. I mean, the shell does kind of glue all that together, so you're really just moving things up in the stack.
yeah, we saw this on one of your slides with the pros and cons.
Mm.
Um, so David does comes with another question. What are the common microfrontends misconceptions you have faced, e.g., component being referred to as a microfrontend and vice versa?
Yeah, so I've either seen it one way of each individual page on your site is a micro front end, which that sort of makes sense in my mind. Where we have if we're processing like an insurance policy or adding somebody into a life insurance claim or life insurance, each page could or would make sense to be its own application. But it's more often than not, I am seeing it as that we have this component or this React piece. We're going to call that a micro front end. It's really not. It's not. Its functionality is not separate. It's not distinct from the rest of the application. So then it's really not a micro front end. It's just, as you stated in your question, a component. So that is the most common one that I've seen is not truly understanding the definition of what an MFE is.
Okay, the next question comes from Risa. If outsourcing the project is part of micro frontend use case, as the outsourced team doesn't have access to the whole source code, can implement with any framework and focus on a specific part.
So if outsourcing the project is part of an MFE use case, um, so I'm a little not quite sure what your question is referring to. Are you referring to like distributed teams? You can follow up with that in the comments or
Yeah, I think the question goes in that direction, but we can reserve it for later on and you can discuss it on the chat after our talk. And from Helda, we got another question. Increasing the bundle size and introducing redundant dependencies. At the moment, what would be the ideal solution to solve improve these scenarios?
yeah. So for redundant dependencies, what I encourage my teams that I work with to do is okay, if you're using it, great, keep it in your application. Do you know of another team or multiple teams that are using that same library? If so, then let's evaluate moving it into a shared library or a shared if you're creating a specifically a shared um, oh, excuse me. Yeah, so let's just stick with library.
A shared dependency.
Yeah, if you have if you have these shared dependencies across multiple applications, then we need to look into, okay, do we need to move that into our common application? But yeah, then that's that balancing act of, is this becoming our junk drawer app? Um, for bundle size, I'm still struggling with trying to figure out how we can reduce the size of these because of, doing that npm install downloads the internet a lot. So trying to make sure that we are only getting the specific libraries we need. So um, improving the scenarios is really evaluating, like, do you need this library? Do you really need this library in your application? Um, and redundant dependencies, and just kind of really we spend a lot of time with our tech leads discussing, okay, we have these libraries and uh, these dependencies, how are we going to orchestrate this? And a lot of times that is, we're putting it into our shared lib.
Okay. Okay, we go on with the next question from Rob. Uh, have you found a situation where it is actually cheaper to define your own custom orchestration rather than purchasing something? In terms of man hours, doesn't the custom solution end up costing more?
Absolutely, it does. It actually can absolutely can end up costing more to build it yourself, because then you have to worry about maintaining it and everything. Um, the only times that I've really found where we are writing our own custom orchestration is when companies get a little hesitant about our our licenses in our open source products. Some some lawyers get very, very concerned about licenses, even though Apache license, for instance, is accepted on other projects and products. They don't want to accept it on this framework, mainly because in my experience, that's been because of a misconception of what open source is. And then there's like, no, you have to build it. We want it in our in-house on our own. So that's the only really time I've seen the custom orchestration, rather than purchasing or um, using a packaged open source app.
Okay, so overall, you can say it costs more if you do it by your own, but if you
Yep.
have some issues like the shared license issues or something like that, then it could be better.
Yeah, it could be better to write your own if there's license issues, but 9 times out of 10, in my experience, it's going to cost you a lot more.
And my personal question is: did you see a situation where it comes to the functionality point, so that you say there is nowhere the functionality which we need, so we do it by our own?
I haven't really seen anything that um, the module federation plugin or single spot haven't been able to really solve. Um, so I haven't really seen anything that open source hasn't already covered.
Okay, I guess this. Then our last question comes from Michael. What are your opinions on code organization for micro frontends using monorepos versus multi-repos approach?
I prefer mono repos, in all honesty. Um, with multi repos, mainly mainly I just don't like having to look through 30 different repos to find what I'm looking for. Um, I found with multi repos, you really have to be careful with your naming standards and your naming conventions. Whereas with your mono repo, you still have to pay attention to those, but I prefer to have everything pulled into one. It does get pushes and get pulls can definitely take take some time. I'm not gonna lie there, but I prefer the mono repo approach.